Hello everyone, this is Prabhashri, Assistant Professor of Mathematics Department, SNS College of Technology. So today I am going to explain an important topic in double integrals which is called as the change of integrations. So in double integration, we evaluate the integration in one variable first. We are treating the other as a constant. We are treating other as a constant and then integrating the second variable with respect to the remaining variable. So we usually integrate either with respect to x-axis or y-axis. In the former case, the limits of the integration are determined in the region by drawing the strips parallel to y-axis, while in the second case we drawing strips parallel to x-axis. So however, if the limits are constant, the order of integration is immaterial, and then the order of integration is immaterial. In such case, we have the limit as which is c to d and a to b. We write the f of x comma dx into dy, which is equal to dy into dx by changing the order of the integrals. So if the limit of the integration are constant, then the order of integrations does not matter. But when the limits are variables, then we have to consider the order becomes difficult or impossible to integrate. In such cases, we change the order of integrations to make the problem easier to do this correctly. So if the limits are on the variables integral f of x comma y is the double integral is either difficult or even impossible, the integration is the order, then we change the order of integration corresponding change is made in the limit of the integration. By geometrical considerations, therefore, a clear sketch of the curve is to be drawn. The limits are applied with responding to the geometrical representations. So, when evaluating double integrals, we either integrate with respect to y first and then x, y, and then this is vice versa. So in this short lesson, we will learn the method of revising the order of integration. Suppose we have the situations of finding the double integral of type 2, that is region is, we consider a region of type 1 as here x is fixed in the type 1 and y is fixed in the type 2. So the x is varies from a to b and then y is varies from g1 of y to g2 of sorry, here they have a represents that is a y, but it's a x. Okay, then the region of type 2 is c is less than or equal to y less than or equal to d, which represents that y is bounded by c and d. The lower bound is c and then the upper bound is d. Then x varies from h1 of x and h2 of x, which is the lower and upper bound, nothing but lower limit and the upper limit. So for this example, we are considering the region. For the first region, first type, we consider the geometrical representation by representing plotting the values that have been given. Let us consider the example. The integral involves the function e power x squared, which cannot be integrated easily with respect to x. So we are splitting the region. So the sketch observes if y equal to 0 and y equal to 2x and x equal to 1, which varies from which x first varies. So we are revising the order, integrating this with respect to y first, which becomes a simples. So this is the main advantages of changing of integrations. So with respect to the next one, we are having type 2. So here we are taking that fixed y and x ranges from y by 2. When the reverse the order, x varies from 0 to 2 and y varies from 0 to 2x. So the limits are rewritten correctly. So it become easier to integrating some by representing this in a geometrical representation. We understand the region that helps in changing the order accurately. So we are going with the example 0 to 2, and then y by 2 to 1 e power x squared into dx dy. So here y is a fixed one, and the range from y by 2 to 1, and then x varies from 0 to 2. So here we are going to draw a geometrical representation, and then we are changing the order of integrations. So we will get there is no elementary antiderivative of integral that cannot be evaluated by performing the integration first. So what we do is evaluate this integral by expressing it as an equivalent to iterated integral with the order of integration reversed. For the inside integration, y is fixed and x varies from the line to line, from outside line to and then outside line to line. So the y varies from 0 to 2. So we get the graph like this. By the line will cut into 1 comma 1. So we will get the two parts of integrations. So this is a two type of a region. So how we could describe the region is by the drawing a horizontal line which is from left to right, which indicates the limit of x, and from bottom to up, lower to up, which represents the limit of y. So here we are splitting the limit as 0 to 2x and 0 to 1. By integrating this we will get the values. So it makes us to integrate the function in a easiest and simple way. So this is the main help of the integration splitting up. So finally, why do we study integrations? So integrations helps us find the position and the velocity. So calculate the areas and the volumes. So design a complex structure like Petron's Towers, Sydney Opera Houses, and even wine casks in history. So changing the order of integration is just not a mathematical trick. It is a powerful tool that helps us to solve the real world problems. To conclude, whenever integrations become difficult, draw the region, understand the limits, and revise the order. Thank you.